Lesson 11b, slope-intercept form of a linear equation. So the slope-intercept form of a line is y equals mx plus b. And the m and the b stand for m is the slope and b is the y-intercept. And the y-intercept is where the line, the point in the graph, that intercepts the y-axis. So this line right here, this first example, it crosses the y-axis right here. The coordinates of that point are over 0, up 3, right? 0, 3. And so the y-intercept, we just put the y value of that y-intercept point. The y-intercept would be 3. And then let's look at the slope. What is the slope of this line? Well, I have to go from one point to another point on the line where I can see that where I know the exact coordinates. So this would be a good choice right here. Any other point along here, I won't know the exact coordinate because it doesn't exactly cross one of the little cross hatches in the graph. So to find the slope here, slope, of course, is rise over run. To get from this first point here to the next, I'm going to rise in the negative direction. I actually have to go down. I have to go down 2, so rise 2, negative 2, because I'm going in the negative direction, and then I'm going to run x in the positive direction, 1, 2, 3, 4, 5. All right, so the slope of that line is negative 2/5. So we're going to plug this into our slope-intercept form of a line. So we're going to say y equals, and then we're going to put the slope here, and the slope is always multiplied to the x, and then we're going to add the y-intercept, which is positive 3, so it's going to be plus 3. If the y-intercept was negative, it would be minus 3. So that's the equation from the graph. Let's try another one. So here, the slope, here's a good point to choose, and it looks like actually right here it's crossing exactly a crosshatch in the graph. To get from one point to another, I have to rise 1 in the positive direction and run 1 in the positive x direction. So the slope is 1 over 1, or just 1. The y-intercept is actually 0, right, because it crosses right at the origin. So let's plug that into our slope-intercept form. Y equals 1x plus 0. The simplest way to write that would actually be y equals x. Because remember, when there's no coefficient in front of a variable, that's the same as 1. So 1x is the same as x. So that's the line y equals x. All right, let's try the next one here. We're actually going to graph it now. So starting with the slope-intercept form, how do we graph it? Well, let's first identify the slope. It's the coefficient of the x in the equation. So the slope equals negative 3. And the y-intercept, in this case it's minus 2, so the y-intercept is going to be negative 2. We're going to first graph the y-intercept, because that is a point on the line. So if the y-intercept is 2, that means this is going to be a point in the line. The line will cross the y-axis at negative 2. Then we're going to use the slope equals negative 3, to find another point. I'm going to put my slope, since it's a whole number, I'm going to put it over 1. It does not change its value, but it helps us figure out how much to rise and how much to run. So from this point, I'm going to rise negative 3, so I'm going to go in the negative direction. 1, 2, 3, and then I'm going to, let's see, I don't want to make that look like a point on the line. Then I'm going to run 1 in the positive direction, and that will get us to this point right here. I could also rise positive 3, 1, 2, 3, and then run negative 1 and get this point. Those are both points on the line. Oops, sorry, I didn't really hit my point there. Okay, let's try another one. Here we have an equation of the line that is not in slope-intercept form, so I don't know right now what the slope or the y-intercept is. I actually have to change it to slope-intercept form in order to know that. I have to get y by itself. So we're going to add 3x to both sides, like so, which is going to leave us with 2y, and I'm going to put the x term first, and then add that 4. We're almost in slope-intercept form, but we have to get y by itself. Right now it's being multiplied by 2. The inverse of that is to divide by 2. And if we divide one side by 2, we have to divide everything on the other side by 2 as well. Those 2's will cancel, and we're going to get y equals 3 halves x, and then 4 divided by 2 simplifies to 2. So there's our slope-intercept form. Now that it's in that form, I can see that the m, or the slope, is 3 halves, and the y-intercept equals 2. So to graph it, we're going to start with the y-intercept. We can't start with the slope. The slope is not a point on the line. The slope is just directions for how to get from one point to another. So we have to start with a point on the line. The y-intercept is positive 2, so that's a point on our line. Then use our slope to find another point. So we're going to rise 1, 2, 3, and we're going to run like this, right? And so I can also, so I rose positive y and I ran positive x. It's a positive sloping line. I could also rise negative 3 and run negative 2 to get another point on the line. There's my line, a positive sloping line. Okay, what about when a line is horizontal? Well, same thing, we got to figure out what's the slope, what's the y-intercept. For a horizontal line, horizontal lines, the slope is 0, right? We have to rise none, and in this case run 1, right? A rise over run would be 0 over 1, which is 0. So slope is 0. Y-intercept, here the scale of our graph is different. Each block equals 2, so the y-intercept is actually 4. Now I can plug that into my equation. Y equals 0x plus 4, slope-intercept form. 0x is just going to cancel, so I'm going to write this as y equals 4. So horizontal lines are always y equals lines. So let's try that right here. Graph the line, y equals negative 2. Okay, well, the slope, I could rewrite this as y equals 0x minus 2, right? Then I could see that my slope is 0. My y-intercept is negative 2. So here's my y-intercept. The slope is 0, so that means it's a horizontal line. There it is, y equals negative 2. There's the graph. What about a vertical line? Okay, what's the slope? Well, for vertical lines, if you remember, the slope is undefined. It is infinitely steep. We cannot give it a number. And the y-intercept does not exist. It never crosses the y-axis. So we can't use slope-intercept form. But we can notice that, let's look at all the coordinates of various points on the line. Here's a coordinate where it's over 3 up 1. Is that coordinate? This coordinate is over 3 up 3. This is over 3 up 4. Notice that every single time the x-coordinate is always 3, no matter what. Every single little point on this line, the x-coordinate is 3. So the equation for this line is actually x equals 3, because x always equals 3, no matter what y equals. Just like over here, y always equals 4. Every single point along this line, y equals 4. Or y equals negative 2. For every point, the y-coordinate of the point is negative 2. All right, let's graph this one. X equals negative 4. Vertical lines, so horizontal lines are always y equals something, right? And vertical lines are always x equals something. So x equals negative 4, so we're going to go to where x equals negative 4. And we could graph a few more points where x equals negative 4, connect them, and we have the line. And that is slope-intercept form in graphing horizontal and vertical.